Okay, in today's lecture, I'd like to go ahead and continue with Unit 3, the I/O management concepts we've been covering. And so up to this point, we've really talked about character streams and byte streams. We start with byte streams, and then we said we can have these character streams that are built on top of the byte streams that do all the encoding of characters for text characters for us. Well, believe it or not, there's also object input streams and object output streams that we can also build on top of byte streams that allows us to create an object stream. And an object stream allows us to effectively put our in-memory Java data into and out to these streams. And when I say Java data, I don't mean just primitive data, but also our reference data, like our not just strings, but like arrays or like custom designed user classes. So in this presentation, I really want to focus in on the object input stream. So a quick overview is we'll do an introduction. We'll look at the class declaration of object input stream. We'll look at the interface for object input. We'll look at the interface methods for object input. We'll look at the constructors of the object input stream class. We'll look at the object input stream methods and some example code. So the object input stream in Java is an input stream, right? Like many of the other input streams we look at, but in particular, this one focuses on being able to read serialized objects from a file. So it doesn't necessarily have to be a file either. I have put file in here, but we can get these, anything that injects the serialized objects into the stream is fair game. Right. Anyway, this particular object input stream, this class is responsible for reading objects, primitive type values, and strings from the byte stream. So in other words, an object input stream is an input stream that deserializes primitive type values, strings, and objects from a stream that was previously written in a file using an object output stream. So since Java object input stream contains all the methods of the data input stream, we can perform input operations for objects in addition to the primitive type values and strings that we've already seen. So we've already looked at the data input stream. Object input stream extends that so that we can now support object types as well. So the data input stream enables us to perform those other input operations for the primitive data types and strings. So we can replace data input stream completely with the object input stream once we learn it for serialization, which we'll talk about this lecture. So the class declaration for object input streams. So our object input stream extends the input stream class and it implements object input and object stream constants interfaces. And so that's going to give us the methods that we need to be able to read objects in. So the object input stream class also implements closable, data input, object stream constants. We already mentioned those two, and auto closable. So I'm going to remove these two because this should just be an addition. Perfect. So these are the default things we typically have membership in whenever we're any kind of stream so that we can close it and get data in. Auto closing, but these are the newer ones that give us the ability to read our objects. So our inheritance hierarchy would look something like this. Inside the java.io package, we have an object input stream, which extends the input stream class, which itself extends the object, as everything is an object in Java. So a quick look at the interface, the object input interface. So that object input is an interface that extends the data input and auto-closable interfaces. It supports object serialization in Java and defines the read object method for deserializing an object. So our general syntax would just be defining an interface called object input. It itself extends the data input. It has one method, that is the read object method. Okay, so in addition to the methods that we inherit from data input interface, which we've already seen in a prior video, the object input interface also defines some useful methods that will be followed. And again, just like all the other methods we've looked at involving streams, there's checked exceptions. So at any time, any of these methods might throw a particular exception. Okay, so the critical methods that we should be aware about is there's an available method. This method returns the number of bytes that are now available to read from that input stream, from that input buffer. We have a close method. This method is used to close the invoking input stream. We have a read method. This method reads a byte of data. Yeah, these are, yep. So most of these are the common ones we've seen. This reads a byte of data, returns an integer from the next available byte, and then -1 if you're at the end of the file. You have the ability to read and pass in a collection of bytes. You can pass in a collection of bytes. Again, we inherit all these methods that we had previously, but the interesting one is this new one here, the read object method. So this method is used to read and return an object from our invoking stream. The rest of these we've all seen before. The skip, where we can skip n number of bytes in our input. We can read bytes at a time. Okay, let's look at some of the constructors of the ObjectInputStream class. There's two of them in particular we want to look at. The first is going to require one parameter. It's going to require an input stream to go ahead and wrap our object input stream around. And so that'll allow us to then read serialized objects from that specified input stream that we'll call inStream. And of course, it throws an IO exception if an IO error occurs, such as the file not opening. So the general syntax to create an object input stream would look like this. We can create generically it would look like this. Using some input stream, we could use the constructor new object input stream and then save that to a variable. More accurately, it might look like something like this. And in fact, let me use let's use a Unix-like file path. So let's say we create a new file and save that file into a file object. And then we'll use that file object to go ahead and open up a new file input stream. And we'll save that into a file input stream variable. And then we'll use that reference to go ahead and open up an object input stream. And then I could use this object input stream to read objects from the stream. And so effectively, we're wrapping the object input stream into the file input stream, and the file input stream is wrapped around the file. The second constructor we have is going to just be a default constructor where we can create an object input stream without any parameters. Now, typically, we'll use the first one. Typically, we'll use this first one here. Okay, so in addition to the methods that we inherit from the input stream, the object input stream class also defines some useful methods to perform input operations on objects. So let's take a look at those. Yep, we already have seen available before, right? That's the number of bytes that are available in our input buffer. We've seen close, and we always want to make sure that we close whatever resources, whatever streams after we're done using them. Okay, we have a new one here, default read object. So this method reads the non-static and non-transient data fields of the current class from the stream. We have a enable resolve object where we can pass in a Boolean value that represents enable. This is used to enable the stream to allow objects read from the stream to be replaced so that we can effectively mutate the state of the objects in the stream. And this returns back a Boolean value, whether that's enabled or not. We have the ability to read. We've seen that before. That just reads a single byte. We can read our primitive data from this stream because it's an extension of the data input stream, which means we could read double data. We could just read and pass in a byte array. We can read Boolean, we can read bytes, we can read characters. We have a read class descriptor. This method is used to read a class descriptor from the serialization stream. We can read the fields. This method allows us to read the persistent data fields from the stream and make them available by name. We have another read float. That's another primitive data type we can read int, read long, read object. That's the big one that we were talking about. This allows us to read an object and return that object from our stream. And again, more abilities to read the primitive data types, read short, read fully, read fully. We've seen all these before. Read fully just reads the bytes, block until all the bytes are read. Let's see here. Read unsigned short, read UTF, that's for reading strings. Skip bytes, and then we can put the number of bytes we want to skip. We have the read stream header. So this method allows subclasses to read and verify their own stream headers. And read unshared. So this method allows reads an unshared object from the object input stream and then returns it. Okay, so let's look at some examples. And so if we're going to use examples of the object input stream, we're going to look at examples using the object output stream simultaneously. So in this first example, what we're going to do is we're going to read and write a student object. And so here, this sample program will just write a student name, maybe a roll number, some marks, percentage, and the current data to a file. Let's say OBJ file or object file, and then we'll read these data using the object output stream and object input stream classes. So here is our source code, but like before, what I'm going to do is I'm going to jump over object input stream tester 1. We're going to go to IntelliJ. I'm going to go to object input stream tester 1 because that's what we're looking at. And we're actually going to run this, and then we're going to take a look at what's happening. So we're going to run. Okay, perfect. Let's see what's happening here. So I'm going to import my file input stream and my file output stream. This is going to give me the ability to both read from a file and write from a file. And so here I'm going to import my object input stream and my object output stream. This will allow me to wrap the object input stream around the file input stream and wrap the object output stream around the file output stream. And this will allow me to take something that is essentially attached to the file and start reading the data instead of as binary data, instead translate it back into Java in-memory data, such as objects or as strings or as primitive data types. And of course, if we're going to do this, we're going to need to also import IO exception, because we need to either throw that IO exception or do a try catch block. And then I'm going to import the date class because I want to actually have an object that I can serialize, that I can put into the stream and then read back out of the stream so that we can see this in practice, and one that implements serializable, which we'll talk more about in just a few moments. So here I'm going to create a new class, object input stream tester 1. I'm going to create a main method here, and I'm going to throw the necessary exceptions that I could potentially have, like a class not found exception if that file does not exist, or an IO exception if for any reason something happens with my IO as I process this. So the first thing I'm going to do is I'm going to create that new file output stream, and I'm going to give it this this label right here. So inside my source directory, I'm going to create a object file in 1.dat. Now, since this is binary data, since our serialization is not human readable, I don't want to use a TXT extension, because TXT conveys to me that, hey, this is supposed to be a human readable file. So whenever we have something that's binary, we can use DAT, data, short for data, to say, hey, this is not a human readable, this is a machine readable file. Then what I'm going to do is I'm going to take this file output stream and I'm going to wrap this new object output stream around it. And so I'm going to have a reference to that OOS, object output stream. Then I'm going to use that OOS, that object output stream, and I'm going to use all those different write methods we covered. So I'm going to write a string using write UTF. I'm going to write an integer, 10. I'm going to write another integer, 44. I'm going to write a double value, 96.55. And I'm going to go ahead and write a new date, right? So I'm going to use that date class there and write that there. So that way we have a more complex reference data type that we're writing to our output stream. And then what I'm going to do after we're done that, I'm going to go ahead and make a new input stream, and I'm going to go ahead and attach the input stream on that same file that we just wrote to. Then I'm going to create a new object input stream, and I'm going to attach the object input stream to the file input stream so that we can translate the binary stream data inside the file input stream into our objects. And then I'm going to use that to go ahead and call the comparable methods in the order that I wrote them in. So I wrote a string. So the first thing I have to do is read a string. So I'm going to pull the string name. I wrote an integer. So the first thing I'm going to do is I'm going to read an integer. I wrote an integer here, 44. So I'm going to read that integer. I wrote a double. So I'm going to read the double here. And then I wrote the object of a date instance. So I'm going to read the object. And so when it reads an object, it's going to be just as the data type object. So then we, in our code, after we read the object, because what gets returned there is an object data type, we then have to cast it into whatever data type we want it to be. In this instance, a date. And then I'll save that into the date variable here. And then once I have all my variables, I'm just going to use a printf statement and print them out to illustrate, hey, I've just authored all of these data, these primitive data types and these reference data types to a file. I read them from the file, and now I'm displaying them to the console. And we can see right here in the console, there it is, the name Ted, the integer 10, the integer 44, the double 96.6, and then the date right here. Yep, and we already explained this. We already went through an explanation of that. And that's it. That's just a quick overview of the object input stream.